Good morning, DeWolf Chemistry students. It's me, Mr. Cheney, with another brilliant tutorial. This one has to do with our virtual lab. It's conservation of mass during combustion, so we call it the rocket lab because we are testing out a virtual rocket. So in order to find this in Google Classroom, this is the exercise here. It's called rocket exercise. Conservation of mass. If you view the instructions, you'll see three things. So for you, the view is your sheets are up here. You're going to open up the sheet. This takes you to the text so that you can do the actual lab, see the rocket go. And this is kind of what the rocket launch pad looks like. So once you click on the spreadsheet, this is what you're going to see. And we have three tests that we'll be doing. And let's navigate to the actual lab. So from here, you can, whichever class you're in, you can actually go from here as well, but that link on Google Classroom will get you there. However, I'm going to go the long way so that I can have my full screen available to me. So I'm going to go here, and here's my lab. So we're going to be bouncing back and forth between the lab and the spreadsheet. And so we'll go to lab and I'll read through all of this. We'll go scenario, investigate, and then the analyze part is where we'll do the lab. So the thundering sound and brilliant lights of a rocket launch is an exhilarating experience. Chemistry is an important part of a rocket launch. A chemical reaction releases energy and gases that expand and escape through the base of the rocket. The gases accelerating downward out of the rocket exert an upward force on the rocket. The force caused by the energy of the combustion reaction does work to move the rocket. Rockets use a common type of chemical reaction called a combustion reaction. In a combustion reaction, fuel reacts with an oxidant, often that's oxygen in the atmosphere, to produce products and a large quantity of heat energy. Like all chemical reactions, combustion reactions demonstrate conservation of mass. The mass of the compounds that react is the same as the mass of the products, meaning what's left over. So moving on to the Investigate tab, we're going to see our launch feature here. Alright, so we have our rocket launch pad, altitude in meters, so obviously we're at 0 because nothing's happened. And so here's our fuel control. We have oxygen in milligrams. We're going to go 3 different levels, 8, 16, and 40. We have hydrogen in milligrams, 1, 2, and 5. So we have ratios of 8 to 1, 16 to 2, 40 to 5. And then the reaction, after these have combined for a combustion, we're going to find and see what the levels are after combustion, and then see what the product is after combustion. So you will fuel rockets and collect data from these launches. From their launches, the rocket fuel is hydrogen. Oxygen is added because it will react with hydrogen, causing a combustion reaction and forming water as a product. So in this case, hydrogen plus oxygen will result in water. This reaction can also be represented as this chemical formula. So 2 H2s plus O2 equals 2 H2Os, so 2 water molecules. The reaction releases a large amount of energy that propels the rocket. The highest altitude the rocket reaches provides a measure of the work the reaction has done. Select each of the controls to discover how they operate. So we'll go to the Analyze screen here, and this is where we'll start our test. So once again, make sure you have your Excel sheet ready to go. We're about to do test number 1. Our reactants are the oxygen and hydrogen being mixed together for the combustion. And then the products right here is, do we have oxygen left over after combustion? Do we have hydrogen? And then do we have water? And then our third column here is the altitude the rocket got. And then we're going to answer the question, mass conserved, yes or no. So here we go with the first test, 8 parts oxygen, 1 part hydrogen. We're going to launch that. And we can see the rocket didn't go anywhere. It wasn't enough combustion to lift the mass of the rocket, so we have 0 altitude. We see that all of the oxygen was used up, and we see that all the hydrogen was used up, and our product from that combustion is 9 parts water. So in our data, we're going to go, we started out with 8. We started out with 1 hydrogen. We burned all oxygen, so none left over, no hydrogen left over. We have 9 parts water. The altitude was 0. And the way that we answer mass conserved is this. If the reactants is equal to the products, then mass was neither created nor destroyed. So mass was conserved. So 8 plus 1 is 9, and 9 equals 9. So yes, mass was conserved. We have the same number. So now we'll go back and do the second and third sets of tests. So we'll reset, bring this up to 16 and 2. We'll launch. And we have some altitude. Thankfully, no humans were in this rocket. We have 20 meters that it got off the ground, but not fully into the air. We used all oxygen, used all hydrogen, and we have 18 water parts. So we're going to go back over here. Started out with 16, had 2 hydrogen, burned all oxygen, so 0, burned all hydrogen, so 0, water was 18, altitude was 20, and is mass conserved? If 16 plus 2 is equal to 18, then mass was conserved, and that is true. 18 equals 18, so yes, we did not lose any of our mass. Last test, reset, bring this up to 40 parts in 5, and we're going to launch. This time we were very successful, got the rocket into the air 100 meters. We burned all oxygen, burned all hydrogen, and we have 45 parts water. Go back over here. Started out with 40 parts oxygen, 5 parts hydrogen. We burned all oxygen, burned all hydrogen, had 45 parts water. Altitude was 100 meters, and was mass conserved. 40 plus 5 equals 45. 45 is equal to the 45 over here, so yes, once again, mass was conserved. And that is your rocket lab. And once you are finished with this chart, and you've done the tests in your textbook, you will turn it in. You'll go back to Google Classroom, you'll see the turn in button, and that's it. That is the rocket exercise conservation of mass virtual lab. I will see you back in class.